Hey everybody, Mr. Stewart here. Let's pick up where we left off in class today. So recall that what you were doing was you were taking the 26 squares. So that is the 1 by 1, the 2 by 2, all the way up to the 26 by 26. And you were trying to create what we called an empty triangle. And specifically, when we left off, I asked that you try to find 3 squares that would make one. And then you contributed some data back towards the end of the period. We were able to collect a few examples of side lengths that we felt might constitute or might form a right angle triangle. Okay, so one thing that we need to do just to finish this off is I am asking for the squares of 3 sides. So that would be the square of side A, the square of side B, and the square of side C. So let's just go through and complete that. So 3 squared, okay, would be 9, 4 squared is 16, and 5 squared is 25. So let's just run through and we'll square each of these values. So 14 squared, I believe that is 196. 16 squared is 256. And 23 squared, that one, let's see, that one's not in my memory bank, so let's grab a calculator and I'm just going to type in 23 and I'm going to use the square to determine that. So 529 is the square of 23. All right, running the rest of them, 13 squared 169, 196, and 20 squared is 400. And last but not least, 7 squared 49, 10 squared is 100, and 12 squared 144. Okay, so you might be wondering, what exactly are we doing with right triangles with their side lengths and the squares of their side lengths? Well, I was a bit concerned because the activity requires quite a bit of precision, and when you are cutting and matching and sorting and trying to measure angles and side lengths with those objects, sometimes we do introduce some error, okay, some measurement error. So there must be a way to tell if the triangle you formed is a right triangle. Okay, so let's think a bit more about what we might see or think we're seeing with the squares of the sides. Okay, so just going to grab a visual here. Okay, so there we have a visual of the empty triangle, and that was this here. This is what you guys were forming in class today, was the empty triangle, and you were building those, right, from using these 3 squares, and they range from anywhere from a 1 by 1 to a 26 by 26. Okay, so if we go back and we take, let's borrow these measurements here. So let's take these 3 right now. Let's use those. Let's bring those forward here. So 3 squared, okay, I'm just going to write that down. 3 squared, that's 9. 4 squared is 16. 5 squared is 25. Okay. Interestingly enough, if you take a look at these 2 measurements here, the 9 and the 16, okay, what we're noticing is that when you add those 2 squares together, okay, it seems as though you are forming the square or the area of the larger square. So when A is 3, when B, the length of B is 5 units, or sorry, that's 4, my apologies, 4 units long, and when C is 5, it appears as though the area of this square, right, which is 9 square units, or 3 by 3, this one, 4 by 4 or 16, and this one 5 by 5, which is 25, okay, that the areas of these two smaller squares are fitting into, or that is, are summing to the area of the larger square. Okay, and I'm realizing now that the way I have my diagram set up, that I'm not paying attention to the scale. So, it stands to reason that these two here, the 9 and the 16, I really should have switched those lengths around. Okay, but if we ignore the scale for now, it seems as though this idea is working out. Okay, and you can do that for any of the measurements. In fact, let's go back. Let's try, well, any one of these would probably be fine. Let's try this one. Let's do the 7, 10, 12. Let's see if that works. Okay. Okay, so this was our first example here. The second one, let's go with side lengths of, let's say A is 7, B is 10, and C is 12. Okay, so if we square the 7, we have 49. Okay, if we square the B, we've got ourselves 100. And lastly, if we square C, that is 12 squared, we'll have 144. Okay. So if the areas of the two smaller squares add together to form the area of the larger square, then we know we've got a right angle triangle. Okay. I'm just going to double check those measurements here, make sure I'm doing okay. Yeah, we're good. So let's try that out. Let's add them up. So I want to take the square of A and I want to add it to the square of B. So that gives me 49 plus 100. That's 149. And C squared is 144. Okay, so right away I can see we have a bit of a discrepancy. Remember last time these added up. Left side equaled the right side, but we can quickly see here, right, that based on those measurements, this is not equal to that. Okay, so in this case we can see that since 149 is larger than 144, it appears as though when I add the squares of the shorter sides, we're not getting equality with the square of the longer side. Okay, and this is a theorem. This is a theory. This is something that you guys have studied previously. Okay, and we're going to need this in our unit on trigonometry. And in fact, I'm going to have you jot down a few ideas. Okay. And this is called the sum of the squares, also known as the Pythagorean Theorem. Okay. And it tells us that the sum of the areas of the two smaller squares, so A squared and B squared, equals the area of the larger square. So visually, just bring this back out and label it. So here's the area of square with side length C. Here's the area B squared of square with side length B. And over here, A squared, the area of square with side length A. And take note that these are the lengths of the sides of a right-angled triangle. Okay, so the Pythagorean Theorem. Okay. Now, if I'm advancing too quickly through the slideshow, if I'm speaking too quickly or you're not catching everything or need more time to jot notes down, pause as much as you want, rewind, fast forward, rewatch until things start to click into place for you. Okay, so that is the Pythagorean theorem. What I'm going to ask for you to do, okay, is this problem may or may not be in your lesson package, but this is something that I would like for you to try. So either in your MSIP or tonight before coming back to class, give this problem a shot, okay? The length of one side of a triangle is 10 centimeters. What might the lengths of the other two sides be of this right triangle? Okay, so I want you to apply what you've been learning or what you've been hearing and experiencing in class today with regards to the Pythagorean theorem. So that's this relationship here. See how that's going to play out for you in addressing this problem. Okay, something that we'll do from time to time is that with every lesson is to try to go back and to spell out or know the learning goals of that lesson. Okay, so I'm just going to pull this out of the way. Okay, so these are or have been the goals of this particular lesson. So numbers 1 and 2, the triangle side inequalities and the angle inequalities, you covered in class. And then number 3, the sum of the squares, you can call that SOS, or you can call it the Pythagorean theorem. That was something that was a focus for today as well. Okay, so you're welcome to write those ideas down. If you go back to the title slide, you'll notice that it is, let's see if I can get us there, relatively blank. So you can add your goals into the space, that's right here. Tomorrow when you come back into class, we'll have a look at the problem, see what kind of solutions you've come up with, and perhaps time permitting, you might have a little bit of time to do some practice problems and maybe a little bit of review in other cases. Okay, all this material will be posted, and some of it already is on the course website. So I'm going to take you there now. You could link off of the course website to this particular page, and what you'll see, okay, on your course calendar is the topic of the day, and you make your way across, and you're going to see some of the learning objects. So here's the practice, here's the notes from the day, and this afternoon I'm going to post the video here. Simply click on the link and it should take you to the YouTube channel. If that doesn't work, or you're not sure how to do that, you can definitely go to the course website, and the quickest way, either from the home page or somewhere in the menu, you're going to see a YouTube button at the bottom. If you click on that, that will definitely take you to the YouTube channel. All right, we'll see you tomorrow.